So today we want to talk about the reagent. Yesterday we finished talking about barium nitrate. Talked about barium nitrate and how to use it. So today we want to look at lead. Into a test tube, add 2 drops of lead nitrate. So here we expect these observations. If you're adding lead to the reagent, then a white PPT is formed. A white precipitate is formed. That simply means that here we are concerned with the lead ions, because all nitrates are soluble. So when lead enters into a colorless solution and then a white precipitate is formed, it means that when the lead ions entered that solution, it met the sulfate. The sulfate ions, so that it forms lead sulfate, which is a white precipitate, or it made the sulfite, which will form lead sulfite, or it made the carbonate, which will form lead carbonate, which is a white precipitate, or it made a chloride. So lead chloride, we know there's a white precipitate. All chlorides are soluble except lead chloride and silver chloride. We know that. So this is the inferences. So if a white precipitate is formed, that is our observation, then our inference is the sulfate, the sulfite, the carbonate, and the chloride ions are present. And the another observation we expect is that no white PPT. No white PPT. So if there is no white precipitate, once you have added lead nitrate, then it means that the sulfate, the sulfite, the carbonate, and the chloride are absent. That's what it means. The third observation, possible observation we expect, is that yellow PPT is formed. So if you add lead nitrate and then a yellow precipitate is formed, then it confirms that inside there was iodide ions present. So lead will enter into that solution, and the lead, if it finds iodine there, it will react with lead to form lead iodide, which is yellow, which is a yellow precipitate. So these are the expectations. These are what we expect when we are using the reagent lead nitrate. Let me go to another reagent, that is a silver nitrate. So what do you expect when you are using silver nitrate? For example, you have been asked into the next test tube, add 2 drops of silver nitrate. So silver nitrate, remember silver forms a white precipitate with chloride ions. So if you add silver nitrate and then a white PPT precipitate is formed, that simply means that inside there was a chloride ions. There was a chloride what? Ion. A chloride ion, which will combine with silver to form silver chloride, which is a white precipitate. We could have said there is a carbonate, but silver carbonate does not exist. I have not seen silver carbonate, therefore we are not going to write a carbonate. Yeah, that's correct. Okay. What else? Sometimes, now, how can we differentiate between barium nitrate and red nitrate? Because when we have this one, we have this, this, and this. When we have this, you can see also we have this. Sometimes, how do we use nitric acid? Now I'm coming to nitric acid. How do we use nitric acid? You will be asked, into a test tube, add 2 drops of lead nitrate, and then you will form this. To the next one, add barium nitrate, 2 drops of barium nitrate, followed by 5 of 2 centimeters cube of lead nitrate. So if, for example, let me say this question, that into the test tube, add 2 drops of barium nitrate, followed by 3 centimeters cube of nitric acid, nitric 5 acid. And then this is the observation. White precipitate is formed, which dissolve in the acid. So if a white precipitate is formed, you are adding lead nitrate, barium nitrate. Remember, barium will form barium nitrate. We will have the carbonate, barium sulfate, and barium sulfite. So if a white precipitate is formed, and then when you add the acid, the white precipitate dissolves to form a colorless solution, it confirms that what was there is the sulfite, 2-, or the carbonate. A sulfite and a carbonate will react with the acid, because initially it will form barium sulfite or barium carbonate. The carbonate will react with the acid, a neutralization reaction, and this one will dissolve to form a colorless solution. So it confirms, if it dissolves to form this one, then you know that this one is present. What if the white precipitate, what if a white precipitate is formed, white PPT is formed insoluble in HCl, in the acid. Now here we are adding barium nitrate. A white precipitate is formed which does not dissolve, meaning that the white precipitate remains. The white precipitate persists. It means it is insoluble. So that confirms that it is going to form barium sulfate. So the sulfate ions will be confirmed present. If it is insoluble in the acid, then SO4 is what is present. So that's how we use nitric reagent. So far we have dealt with this and this one, silver nitrate, lead nitrate. We have finished. So please allow me now to go to a real example, and then we can see how we are supposed to handle. Let us look at this question. There's a question here. Okay. So the procedure is that heat about a half of solid N, we have been provided with solid N, into a clean dry test tube. test any gas produced using a moist blue and red litmus paper. And then your observation is that a colorless liquid is formed at the cooler part of the test tube. And then a blue litmus paper turns red, red remains red. So if a blue litmus paper turns red and red remains red, it means that whatever was produced, the gas was acidic, because now red will remain red because it is acidic, and blue will change red. Therefore, in the inference, you will say, you can say that hydrogen ions present, or you will say acidic gas produced. Acidic gas produced. A colorless liquid, it means the salt that was burnt is an hydrated salt, so hydrated salt present. Or you can say water of crystallization. Water of crystallization. Now let me go to part 2. I'm concerned with part 2. Take a spatula end of N in a test tube and add distilled water until a half filled. Shake well and divide the solution into 5 portions. So N dissolves to form a colorless solution. So if the solid you have been given dissolves to form a colorless solution, it means that so many salts are there: magnesium, aluminium, zinc, all of those are there. But now, to avoid writing all of them, we will write the colored ions that are present, which are absent. So we will write that Cu2 positive, which is blue, ion 2 positive, which is green, and ion 3, which is brown, is absent. Meaning, because it is a colorless solution, meaning copper, which is blue, is absent, ion 2 is absent, and lead is absent. That is the easier way of writing it that one. Now, to the first portion, we have now divided into 5 portions. To the first portion, we are adding sodium hydroxide dropwise until in excess. So here we need to give observation in twice. Once using drops and then in excess. So when you add 2 drops, a white precipitate is formed. When you add 2 drops, a white precipitate is formed. But then when you add in excess, the white precipitate dissolves to form a colorless solution. So we have said that when we are using sodium hydroxide, we are simply testing for ZAP, which is the amphoteric oxides. So this means that there is zinc, there is aluminium, and there is lead. These ones are what? Are present. That's what it means. To the second portion, add 2 more sodium hydroxide ammonia solution, dropwise until in excess. So here you give observation dropwise and then finally in excess. You don't generalize. Therefore, when you add 2 drops, what happens? A white precipitate is formed. And this white precipitate, when you add in excess, it dissolves in excess. So if it dissolves, remember it is going to form zinc, the complex of zinc. So if it dissolves, it means that the zinc 2 ions are present. But if it does not dissolve in excess, then it means either aluminium or lead are present. Or you write zinc 2 ions absent. If it does not dissolve in excess ammonium hydroxide, you write zinc 2 positive absent. But I have already explained why we are going to talk about this in our previous video. To the third portion, add 2 more HCl. So we are adding HCl. Here we are concerned about the chloride ions. So no white precipitate. So if there is no white precipitate and we are adding HCl, the chloride ions, it means that the lead ions is absent, absent. Now you can ask me, why didn't I say silver, Ag, because silver chloride is a white precipitate? Why didn't I say Ag absent? I did say silver absent because here we didn't include it. It was not there. Therefore, we are eliminating these ions. This is the. Therefore, we have said this one is present. It means this one is absent, right? So there's no way I'm going to introduce silver here now. Silver here, I'm not going to introduce it. So that's okay. To the fourth portion, add 2 more lead nitrate. Then a white precipitate is formed. So we are adding lead, and whenever we add lead, a white precipitate is formed. It simply means that there is a sulfate, 2 ions, there is a sulfite, this is negative, there is a sulfate, a sulfite, a carbonate, or a carbonate, yes, even a chloride, because here we don't limit, so this one are present. To the 50th portion, add barium solution, barium nitrate solution followed by dilute nitric acid. So here we are adding barium nitrate, then followed by dilute nitric acid. That could be about 5 centimeter or whichever. So then a white precipitate is formed insoluble in the acid. So if a white precipitate is formed and that white precipitate is insoluble in the acid, we have said this one is not there, this one is not there, and this one is not going to be there. So what is going to be there is the sulfate, which is confirmed. This is one that's going to be present. So it is as simple as that. We will do more of this so that you can be convenient, you can be familiar with these things. Thank you. Please subscribe. We love you all.